Dear student, in today's session, we will discuss very basic chapter of chemistry, that is some basic concepts of chemistry. We can say that this chapter is ABCD of physical chemistry. It means very important and very basic chapter for physical chemistry point of view. So we will see what topics are to be covered in this session. So first of all, we will see atomic and molecular masses, mole and Avogadro number, molar mass, convergence, percentage composition, empirical formula, molecular formula, stoichiometry, balanced chemical reaction, and limiting reagent, and some basic concentration terms is used to determine amount of solute in solution, or we can say amount of solvent in solution. And finally we will see combustion reaction. Basically in this section we will cover basic concept of mole, then we will see concentration term, we will see combustion reaction, and some important questions. So what is atomic mass and molecular mass? Atomic mass means mass of an atom, and molecular mass is mass of an molecule. So before this, I want to tell something about atom and neutron, proton, electron, what is mass of these particles, etc. So in an atom there are three subatomic particles: proton, electron, neutron. And we tells about mass of these particles. Proton has mass of 1 mu, electron has mass of 1 divided by 1837 amu, and mass of neutron is also 1 amu. So for atomic mass calculation, I have an example 7 nitrogen 14. Everyone know that what is the number of proton in this? So proton is 7, number of electron also 7. This number is proton, this number also electron in neutral species, and this minus this 14 minus 7 is number of neutron. So we have seen that these are the number of proton, electron and neutron. We know mass of proton is 1 mu, mass of neutron is 1 mu, mass of electron is this. So if we calculate mass of entire 7 proton, that will be 7 mu, because 1 proton has mass of 1 mu, then 7 proton has mass of 7 mu. Electron 1837 amu, and this is 7 amu. Now total mass will be this plus this plus this, so this will be 14 amu plus something. So something is what? I think you understood, amu. So this quantity can be neglected with respect to this. So we can say mass of a single nitrogen atom, mass of single nitrogen atom is 14 amu. Okay, then now I take an example of sulfur. Sulfur, you know, 1632. So we can say proton is 16, electron is also this number, and neutron will be this minus this. So neutron will be 16. We know mass of single proton is 1 mu. So mass of 16 proton will be this. Electron, for that we can say mass of electron is 1837 amu, and now you can say 16 AMU. Then you will calculate entire mass of this atom. This will be this plus this plus this. Then this will be 32 plus something, or something can be neglected. It means we can say 32 AMU. It means mass of single atom will be 14. If there is a number of 14, then we can say 14 AMU. If there is a number of 32, then we can say 32 AMU. It means mass of single atom will be this number multiplied by AMU. Then now we go for molecular mass. Let's example of CO2. CO2 is a molecule. CO2 contains one carbon atom and two oxygen atom. One carbon atom will be 6C12 and one oxygen atom will be 816. Now for one carbon atom mass is 12 AMU and for two oxygen atom mass is 16 multiplied by 2, 32 AMU. Now you can say mass of CO2 of one molecule will be one carbon atom has mass of 12 AMU plus one oxygen atom has mass 16 AMU. Then you can say total mass of one CO2 molecule will be 32 plus 12. It means 44 AMU. So we can understood basic meaning of atomic mass and molecular mass. It means we can say mass of an atom in AMU is atomic mass, mass of an molecule, that is molecular mass. Now there is an example also, H2SO4. We have to calculate molecular mass. We have to calculate molecular mass of H2SO4. Now you can say for H2SO4 this has 1 AMU multiply by 2, sulfur has 32 AMU plus 4, oxygen has 16 AMU. Then this will be 98 AMU. You can see this is molecular mass of H2SO4. Now if you understood this, then we start with molar mass. What is molar mass? We can say what is basic difference between atomic mass or mass of an atom, mass of a molecule and molar mass. Before molar mass we have to understand what is mole. So mole is a quantity which represent 6.02 multiply 10 raised to power 23 particles. This number is known as 1 mole. This number is known as 1 mole. If I have these number of atom, or I can say this quantity also known as Na. Na is a symbol for this, and we have known this number as a Avogadro number. So now we talk about some examples, like for example you have 6.02 multiply 10 raised to power 23 marker. Then you can say you have 1 mole marker. If you have these number of electron, then you can say 1 mole electron. It means I want to say that these number represent 1 mole. Okay, so now we can define what is molar mass. Molar mass means mass of an atom or molecule in gram for 1 mole. It means we have to calculate mass of an atom or molecule. For this we have to take 1 mole atom. Here is a definition: molar mass, mass of 1 mole, mass of 1 mole of substance. 1 mole substance लेना है, उसका जो भी मास होगा वो क्या हो जाएगा, मोलर मास. For example, I have oxygen 816, and I have to calculate molar mass. Then we know molar mass is what? Molar mass is mass of 1 mole substance. So we have to take 1 mole, then what is the mass? So we know single atom has mass of 16 AMU, and 1 mole means Na atom. 1 mole means we know 6.02 multiplied 10 raised to power 23, it means Na. So we can say 16 AMU multiplied by Na. This is mass of single particle and this is mass of 1 mole particle, it means Na particle. And I tell you 1 AMU is 1.67 multiplied 10 raised to power minus 24 gram. And if we have used this equation here, and Na is 6.02 multiplied 10 raised to power 23, then you will find 16 gram. It means you have to remember 1 AMU multiplied by Na is 1 gram. This is very important result. 1 AMU multiplied by Na, this is 1 gram. So we can say mass of single atom is 16 AMU. Mass of single atom is 16 AMU and mass of 1 mole atom is 16 gram. For example, we consider molecule, then you will see mass of single H2SO4 is 98 AMU, and if we are talking with 1 mole, then you can say mass of 1 molecule is this, and mass of Na molecule means 1 mole. So this is mass of 1 mole. This mass can be written as 98 gram. Finally, I want to conclude that if we have single atom, single molecule, for example, if you have single nitrogen atom, then you have mass 14 AMU. If you have 1 mole nitrogen atom, then you have mass 14 gram. If you have H2SO4 single molecule, then 98 AMU will be mass. And if we have 1 mole, then mass of H2SO4 is 98 gram. Okay. Now this was about atomic mass and molecular mass. Now which are talking that is 1 mole is 6.022 multiplied 10 raised to power 23 particles, that is known as Avogadro number also. And there are some basic formulas for mole calculation. I want to discuss these formulas together so that we can connect formulas each other also. If you have a number of particles, then you have to divide by Na for calculation of mole. If you have given mass, then you have to divide molar mass, which I have discussed. If a condition is STP, then volume in liter is given. Then you have to divide 22.7, then you will find number of mole. So for mole calculation, we have 3 formulas that are very basic formulas. So we will connect these formulas together. So let's see. These 3 formulas are on a screen. Mole, given mass divided by molar mass. And this formula will be used to convert mass into moles. This is number of particles, this is Avogadro number, this is mole, and finally this is volume, this is number of mole, 22.7. When we are using STP condition, then this formula can be applied. Now I want to connect these 3 formulas. For example, you have given mass, then you have to divide by molar mass to calculate mole. If you have number of particle, then you have to divide by Na to calculate number of mole. And if you have volume in liter, then you have to divide 22.7 for STP condition. If condition is STP means pressure should be 1 bar and temperature should be 0 degree centigrade. If these conditions are fulfilled, then condition is STP. And in STP condition, if volume is given in liter, then you have to divide 22.7 for mole calculation. So these are mole calculation formulas. So if mass is given in gram, then you will use this formula. If number of particles means atom, molecule, electron, proton, etc. If these are given, then we have to use this formula, and volume at STP is given, then we have to use this formula. If mass is given and volume we have to calculate, then we have to go for first mole, then we have to go for volume. If number of particle is given and we have to calculate volume in liter, then you have to go first for mole, then volume. If you have mass and you want to go for number of particle, then you have to go this and then after this. I want to say for each condition you have to calculate mole, and after calculating mole you can connect mass, molar mass and volume by each other. So this was about YMAP. YMAP is conversion of mass into volume, mass into number of particle into volume, volume converts into mass. For that, these are three formulas. This is some basic problem in which mass is given and you have to find out number of atoms. So we'll start. Here is H2O. For H2O, 1.8 milligram H2O. So first of all, 1.8, this is mass in gram, divide by molar mass, and for water molar mass is 18. So this is number of moles, and if we calculated moles, then you have to multiply by Na. This will give you number of particle, and here particle is H2O. So mole multiply by Na, this is number of molecules. This is number of molecules of H2O, and single molecule contains 3 atoms. Single molecules contain 3 atoms, 2 hydrogen atom and 1 oxygen atom. So we can say total number of atom will be 3 times of number of molecules. The number of molecules is 1.8, 18 multiplied by 10 raised to power minus 3 multiplied by Na. These are the number of atoms. So if we want to match these things, you can say 3 multiplied by 10 raised to power minus 4 Na atoms. Now we will talk about H2SO4. So this is H2SO4, and H2SO4 8 milligram 10 raised to power minus 3, this is gram divided by 98. I think this is moles, and we have to multiply by Na. Mole multiply by Na will give you number of molecules, and we know single molecule of H2SO4 contains 2 hydrogen, 1 sulfur atom and 4 oxygen atom. It means this is 7 atom in a single molecule. Now if we want to talk about that how many number of atoms are there in all molecules, then we can say this will be the number of atoms in H2SO4. Now we will talk about carbon. So carbon is given 1.8 milligram 10 raised to power minus 3 divided by, we can say for carbon this is 12, This is number of particle, and in this condition particle is atom. So this is number of carbon atom. Now we are talking about NaCl. Then you will, this is 5.85 milligram, this is minus 10 raised to power minus 3, and this is mass in gram, and this is molar mass. 58.5 is molar mass for NaCl. This is mole, and multiply by Na. If we are talking this, then this will be molecules of NaCl, and one molecule of NaCl contains two particles, one sodium and one Cl. Then we can say these are the number of atoms of in NaCl. So we can match by solving these. So next, we can match by solving these. Another question is, which of the following contains same number of atoms? So we have to calculate number of atoms. First is 2 gram oxygen gas, O2 gas. So 2, this is mass, and I think this is moles of oxygen. What we did? We have did that मास डिवाइड बाई मोलर मास. मोलर मास ऑक्सीजन का कितना होता है? O2 की बात करना चाह रहा हूं मैं, और यदि अपन O2 की बात करेंगे तो 32 ग्राम. दिस इज मोल. नाउ दिस इज molecules of O2, and one molecule contains 2 atoms. Then this will be the number of atoms of oxygen. Now for second option, 4 gram SO2, then we can say 4 divided by molar mass of SO2 will be 64. This is moles, and if we multiply by Na, this is molecules, and one SO2 molecule contains 3 atoms. Then we can say these are the number of atoms. So I think this is also 4Na divided by 6. I think 4Na divided by 32. 4Na divided by 32, and this is I think 6Na divided by 32. Okay. Next, in C part, 1400 ml 1400 ml 1400 ml O28 STP. So we have to convert this in liter. So this is the volume of the O28 STP, and now we have to divide 22.7. This will be the mole of the O2, and now these are the molecules and these are the atoms of oxygen. And now for helium, we can say 0.05 liter and 22.7. These are the mole of the helium, multiply by Na. These are the number of atom. So this is volume, this is mole, multiply by Na. This is the number of helium atom. Now in last 0.0625, 1 minute. In last 0.0625, this is mole of H2. If we multiply by this Na, this will be the molecules of H2, and this will be the number of atoms of hydrogen. So by this we can calculate in each case what is the number of atoms, and then we will find which are the same number of atoms in which of the following cases. Then we will decide. Now next is percentage composition and formulas. So what is the percentage composition? Here is mass percentage of an element. Formula is mass of element in 1 mole compound divided by molar mass of compound multiplied by 100. What is mean by this? If we example of CH4, if we take example of CH4, then you have to take 1 mole of CH4. So what is the molar mass of CH4? It's 16. And for which element you want to calculate percentage, that will be, if I assume for carbon, so you have to write mass of carbon present in 1 mole of this. So you have to take 1 mole. I have taken 1 mole CH4, mass of this is 16, and in this 1 mole CH4 mass of carbon is 12 gram, multiply by 100, this is mass percentage. And if you want to calculate for hydrogen, then you have to write 16 is the mass of 1 mole CH4, and mass of hydrogen in that is 4 multiplied by 100, so this is mass percentage. Empirical formula is what? Empirical formula and what is a molecular formula? Empirical formula tells about simplest whole number ratio of various atoms present in a compound, whereas molecular formula tells about exact number of atoms present in a compound. So how we can calculate, and we take some basic example for empirical formula. So there is C6, or you can say glucose. You can say glucose. So what is this C6H12O6? So in glucose, one molecule contains 6 carbon, 12 hydrogen and 6 oxygen. But simplest ratio will be C1H2O1. This represent empirical formula and this represent molecular formula. Another example, C6H6, then you can say C1H1. Another example is CH4, then this is also simplest ratio, then you have to write CH4. Now you will see that empirical formula will be multiplied by some coefficient for obtaining molecular formula. If I multiply by 1, then you will calculate this. If I multiply by 6, then you will calculate this. If I multiply by 6, then you will calculate this. So you can say that what is N? So you can say this is molar mass, this is empirical formula mass. Acha, what is this mass of the empirical formula in this example? Then you will say mass of this empirical formula, carbon 1, hydrogen 2, oxygen 1, this will be 30. Multiply by 6. And for this glucose is 180, then you can write this is N, so N will be 6. It means N can be calculated by dividing molar mass divided by empirical formula mass. Then you can understand this formula how I can write. If you can calculate N, then you can write empirical formula multiply by that number, it means N, then you will get molecular formula. So we can calculate by a example. Before this, there is a simple example of H2O. What is the percentage of hydrogen in H2O? So for this is a total weight of H2O is 18 gram and weight of the hydrogen is this, multiply by 100, this is percentage of hydrogen. And if we can calculate, if you want to calculate for oxygen, then you have to write 18, this is molar mass, and in above you have to write 16 multiplied by 100. This is the percentage of oxygen. So we take a simple example for empirical formula. Now, this is an example. An oxide of iron contains 69.9% iron. Its empirical formula is हमें बताना है. So, first of all, you have to assume total mass equal to 100 gram. First of all, you have to assume total mass equal to 100 gram. So let's total mass is 100 gram. We have to assume in this mass of the iron is 69.9 and mass of oxygen is remaining. So I think remaining is 30.1 gram. Sum of these two masses will be 100. Now we have to calculate number of moles. 69.9 divided by iron has molar mass of 56 and 30.1 divided by 16. So I think these are the number of moles of iron and oxygen in this sample. Now you have to calculate number of atoms. For number of atoms, you have to multiply by Na. We know number of moles multiplied by Na is number of atom. Now we have to take simple ratio. If you take simple ratio, then you will be find 1 3 by 2. We have to find simplest formula. For that you have to multiply by 2. Then you will find 2:3. It means iron will be 2 and oxygen will be 3. Then formula will be Fe2. Iron is 2 and oxygen is 3. So formula will be Fe2O3. Now in next, stoichiometry and reaction calculations. So what is stoichiometry? This concept is valid for balanced chemical reaction. It means it is very important to balance first chemical reaction, then you have to apply stoichiometry. Stoichiometry is basic concept. If we an example of Haber process in ammonia preparation, then you have write simple example is N2 plus 3H2 converts into 2NH3. What are the stoichiometric coefficient? 1, 3, 2. So if how we have to read the reaction by stoichiometric coefficient? We have to read 1 moles of N2 will react with 3 moles of H2 and form 2 moles of ammonia. This is basic thing of stoichiometry. So it is very important that we have to balance chemical reaction very carefully, then apply stoichiometry rule or mole concept. Here is simple procedure for stoichiometry and calculation of reactions. Here is a simple example, 2H2 plus O2, 2H2O. I read that 2 moles of H2 react with 1 moles of O2 and form 2 moles of H2. Here is written that 1 mole of O2 produce 2 mole of H2. 1 mole of O2 produce 2 moles of H2 when H2 is in excess, when H2 in sufficient amount. So what is mean by that H2 is in excess and O2 is in limited? So for that we have to define a new term, limiting reagent, and this is known as LR. So what is meant by LR? LR is a reagent which consume first in balanced chemical reaction. Here are two reactant. Which reactant will consume first in balanced chemical reaction? That will be LR. Here H2 is in sufficient amount, and if I take H2 in excess amount and O2 is taken as a in limited amount, then O2 will be known as limiting reagent, and further reaction will be proceed or calculations will be done using limiting reagent. So we take an example for LR calculation. So what is a limiting reagent? I already told about limiting reagent is what. So basic fundamental method is what for calculation of LR. So for that we have to take an example. For example, there is two reagent A and B, A and B, and X moles of A and Y moles of B is given. Now we have to find LR. So basic approach is that mole, we have to divide mole by stoichiometric coefficient. We have to divide mole by stoichiometric coefficient. This is X upon A, this is Y divided by B. Which value will be minimum? That is known as LR. So if X by A is less than Y by B, then you have to tell that A is limiting reagent. If this is, then you have to tell that this is LR and this is equal, then A and B both will consume simultaneously. It means no reagent will consume first. It means no LR. If X upon A barabar Y upon B, then you have to tell that no LR. So in this slide, whatever I told you, that is written. What is that? Na moles of A divided by A, moles of B divided by B, or we have to compare. If mole divided by stoichiometric coefficient, mole divided by stoichiometric coefficient, which value will be lesser? That a corresponding reagent will be LR. So in this question, A plus 2B converts into AB2, and what is A? A is 36 gram and B is 56 gram. So A plus 2B converts into AB2. A is 36 gram, this is 56 gram. First of all, we have to find out moles. So moles of A is 36 divided by molar mass. Molar mass is 60. Then this will be 0.6 mole. And for B, moles of B, this will be 56 divided by 80. This will be 0.7 mole. Now you have to find LR. What is LR? LR is moles divided by stoichiometric coefficient. Moles divided by stoichiometric coefficient is 1. Moles divided by stoichiometric coefficient. This is for A, this is for B. Mole divided by stoichiometric coefficient. Which one is minimum? This is minimum. So this will be 0.6, 0.35. So we can say B is LR. We can say B is limiting reagent. So B is LR. LR will consume first. So this is 0.6, 0.7. So 0.7 minus 0.7, yani B completely reacted. When B react 2 mole, then A will be 1. So we can say this will be 0.6 minus 0.35. I think you understood. We can say when react with 2, then this will be 1. When react with 1, this will be half, then 0.7, then this will be 0.35. Now this will be remaining moles of A. What will be AB2? This is 2, this is 1. So this will be 1 by 2 multiplied by 0.7. These are the moles of AB2 formed. So in second option, mass of 0.77 gram of AB2 is given. So if you want to calculate mass of AB2, then you have to write moles and molar mass of AB2. Molar mass of A is 60, B for B is 80, AB2 for this is 160. Then this will be, I think, 220. This will be 220 and multiply by 0.7 divided by 2, this will be 110 and this will be 77 gram. So B is correct option. Molar mass of AB2 is 140 gram. So this is molar mass of AB2 and this is 220 gram. Now 15 gram of A is left unreacted after the completion of the reaction. So this is left amount of A. What is this? Left amount of A is 0.6 minus 0.35. So this is 0.25. I think this is clear. This is clear. Then mass is will be multiplied by molar mass is 60. Then this will be 150. 15 gram of A left unreacted after the completion of the reaction. So option B and option D are correct option. Next, mass of iron converted into Fe3O4 by the action of 18 gram of steam is. So reaction will be iron plus steam will be converted into Fe3O4 plus H2. If you want to balance the reaction, 3Fe, then 4H2O, then 4H2O, Fe balance H2O balance and this will be 4H2. Now 18 gram of steam, mass of iron converted into Fe3O4 by the action of 18 gram of steam. 18 gram steam, how much iron can be converted by the steam? Now you can say 18 divided by 18, this will be 1 moles of steam. Now I assume that mass of iron is x gram, then this will be x upon 56, this is moles of iron. Now you can say that if 4 mole of steam react with 3 mole of iron, then 4 mole of steam react with 3 mole of iron, 1 mole steam react with 3 by 4, and here we have 1 mole of steam react with 3 by 4 mole of iron. This will be x by 56. Now you can calculate this x 42 gram. So by this we can solve it. So beta, now we will discuss concentration terms. Concentration terms are used to decide what is the amount of solute and solvent present in solution. So first is mass percentage, mass of solute, mass of solution multiply by 100, percentage volume, volume of the solute divided by volume of the solution multiply by 100, ppm part per solute per 10 raised to power 6 parts of solution. It means what is ppm? ppm is mass of solute divided by mass of solution multiplied by 10 raised to power 6. If you have to define ppb, then you can say this multiplied by 10 raised to power 9. Mole fraction is number of moles of solute divided by number of total moles. Molarity, number of moles of solute, volume of the solution in liter. Molality, moles of the solute divided by mass of the solvent in kg. Next, what is the basic difference between molarity and molality? Don't mix them. Molarity, moles of the solute, but here is liter of the solution, volume of the solution in liter. This is mass of the solvent in kg. This is basic difference, that here is volume of the solution in liter and here is mass of the solvent in kg. Depends in volume, depends in mass. Concentration term which involve volume, that depends on temperature, and concentration terms which does not involve volume are independent from temperature. So next, now this is simple question related to concentration term. What is the mole fraction of water in 10 percentage W by W of the aqueous urea solution? Aqueous urea solution. So what is mean by this? What is mean by this? Definition tells about that 100 gram solution contains solute is 10 gram. So for every concentration term you have to find mass of solute, mass of solvent, mass of solution, by which you can calculate or convert any concentration term into another concentration term. So this is mass of the solution, this is mass of the solute, then mass of the solvent is 90 gram, because this is mass of the solution, this is mass of the solute, this minus this is mass of the solvent. Now we have to calculate mole fraction. What is mole fraction? Mole fraction of urea will be moles of urea, which I tell small n, moles of urea divided by capital N, moles of solvent. So 10 divided by urea, this is moles of urea, this is moles of urea, and this is water. So if you calculate, this is 1 by 6, 1 by 6, this is 5. Then this will be, I think, 1 upon 31. I think 1 upon 31. By this we can calculate mole fraction. If you calculate this, this is your answer. Now these are basic formulas in entire session. For mole calculation, mass divided by molar mass, mass divided by molar mass, number of particles divided by Na, volume divided by 22.78 STP, Next, this is mole fraction, this is molarity, this is number of mole calculation, whichever we already seen. Next is combustion reaction. What is mean by combustion? Basic meaning of combustion is we have to burn compound in excess of oxygen, C3H8. Propane is burnt in excess of oxygen, then carbon converts into CO2, hydrogen converts into H2O. During combustion, following changes occurs: carbon converts into CO2, hydrogen converts into H2O, magnesium if present, MgO, nitrogen if present, converts into N2, calcium is present, converts into CaO, sulfur is present, then converts into SO2. These are following changes occurs. Now, if you want to balance combustion reaction, first of all you have to balance carbon. There is carbon is 3, then this is 3, then hydrogen is 8, so we have to write 4, then oxygen is 4 and 6, then this will be 5. So there is a simple question. I can say 60 gram of this is burnt in excess of oxygen, 60 gram of X is burnt in excess of oxygen. Then what will be the mass of CO2 and H2O will be formed? This is question. So first of all you have to calculate the molar mass of this. The molar mass of this is carbon is 12, so 36 and 8 for this hydrogen. So this will be the moles 60 and this is 44. And this is axis, it means this is LR, limiting reagent. Reaction will be proceed in terms of LR. So we can say 1 mole of this will consume and 3 moles of CO2 will be formed. So this will be 3 times of this 60 upon 44. And this will be, this if this is 1, then this will be from 4 times, so this will be 460 upon 64. This is the moles. If you want to find out the mass, then you have to multiply by molar mass. You have to multiply by molar mass 18 gram. So this was about combustion reaction, how we can calculate the mass of the product formed. And balancing of the combustion reaction. For balancing of the combustion reaction, there will be certain pattern. First we have to balance carbon, then we have to balance hydrogen, then we have to balance oxygen. So we seen entire basic concept of chemistry, mole concept, concentration term, and we can say combustion reaction related things. So this will be very helpful for your score examination. What is score examination? India's largest talent search exam, by which you can get case reward, scholarship, educational trips, etc. So this slide itself tells about what is the features in a score examination, that is case rewards, scholarships, educational trips, and many more rewards you can achieve. And for this there are 4 steps. First of all, we have to registration process, then verify by filling details and select your exam center, timing also you can select, and Third step is some small amount charges for this examination, and finally you can attempt your test. Next, these are exam dates for scholarship for school and college student for Sri Chaitanya, and these are the exam date for Sri Chaitanya Coaching and Academy, and that is 11th October 2026. And this is our website www.srichaitanyascore.com. You can Google this website, go and see all features related to score examination. And you can like, subscribe, share these our social media platform by which you can get further updates regarding score examination at Sri Chaitanya. So for now, all the best beta for your score examination.